Hello again. This time I'm working through section 2.2, problem number 60. In this problem, we're told that g of x is equal to 1 over x, and we're asked to find the derivative of the function at x equals 2 algebraically. And remember, the derivative of the function is just another way to say what's the instantaneous rate of change at that point in the function. So we'll start with our difference quotient, which tells us that g of a 2 plus h minus g at 2, that's the change in my outputs, divided by the change in my inputs, that's my average rate of change. And since I'm looking for the instantaneous rate of change, I have to take the limit as h approaches 0 of that expression, and that is my derivative of the function g at 2. Okay, so now I'm going to, like last time, I'm going to go ahead and now change from function notation to my actual function that I'm working with. So I have to take the limit as h approaches 0 of g at 2 plus h is 1 over 2 plus h. Subtract from that g at 2, which is 1 over 2. Divide that change in the outputs over h, which is the change in the inputs. Okay, now I have to combine these two fractions in order to do the subtraction. So I'm going to come off to another page here to see what that looks like. So if I have 1 over 2 plus h, and I want to subtract from that 1 over 2. Just a quick review of fractions here. I need common denominators. So I am going to multiply in this fraction here, I'll multiply the numerator by 2 and the denominator by 2. And then with this fraction over here, I will multiply the numerator by 2 plus h and the denominator by 2 plus h. And then that would give me, all said and done, the fraction on the left is 2 over 2 times 2 plus h. I'm not going to multiply those out. I'm going to leave it like that for now. Minus 2 plus h over 2 times 2 plus h. So now you can see that I have a common denominator, so I can do the subtraction. And this would give me 2 minus the quantity 2 plus h all over 2 times 2 plus h. Okay, so that's what I get when I combine my original fraction into my subtraction of these two fractions into this one fraction. So let me go back and substitute that in over here. So what I have now is the limit as h approaches 0. Remember, I combined these two and I got 2 minus 2 plus h all over 2 times 2 plus h. That's just my numerator. Divide the whole thing by h because we're looking at the limit as h goes to 0. The change in my output goes to 0. All right, now I've got to clean this up a little bit. So let's say that is equal to the limit as h approaches 0. First of all, 2 minus 2 is 0, and then I have the minus h all over, this time I will go ahead and multiply this out, 4 plus 2h. And then I'm dividing that whole thing by h. Okay, I'm going to do one more little algebra step here. Take the limit as h approaches 0. Dividing by h is the same thing as multiplying by 1 over h. So I'm going to rewrite this expression as negative h over 4 plus 2h, that whole thing multiplied by 1 over h. So instead of dividing all of that by h, I'm going to multiply by the reciprocal, which is 1 over h. If fractions still bother you, now's a really good time to get some good practice with the manipulation of fractions. All right, now let's see what happens when I multiply these two expressions together. This would give me the limit as h approaches 0, okay, of negative h over, multiply the numerators, multiply the denominator, h times 4 plus 2h. And I'm going to clean that up a little bit. H divided by h gives me 1, so that would give me the limit as h approaches 0 of negative 1 over 4 plus 2h. Okay, now I want to take the limit of this expression here as h approaches 0. So as h approaches 0, I can see that in my denominator, 4 plus 2 times a number really close to 0 is really just the same thing as 4 plus 0. That's what it's approaching, 4 plus 0. So the limit of this whole expression right here is going to equal negative 1 over 4. Okay, let's take a quick look at that again. I'm taking the limit of this expression. The negative 1 is not affected by h approaching 0 at all. So the negative 1 in my numerator is going to still be there. And then the 4 plus 2h, as h approaches 0, simply approaches 4. So now I know that my derivative of g at 2 is equal to negative 1/4. Okay, I hope that helps. Let me know.